multiple choice questions. This one is on KC. Just a quick recap from AS. Question 3. The ester methyl ethanoate is hydrolyzed as shown in the following equation. The equilibrium yield of ethanoic acid could be increased by adding in catalyst. Absolutely incorrect. Incorrect. That will not increase equilibrium yield of ethanoic acid, which is this. Lowering the temperature. Well, the forward reaction is endothermic. So if I lower the temperature, it's going to want to increase the temperature equilibrium. So it's going to shift to the side, to the exothermic direction to oppose the decreased temperature, aka increase the temperature. So it's not lowering the temperature. Adding more water to the reaction, make sure you add more water. Yeah, then the equilibrium is going to shift to the right hand side, and therefore equilibrium yield ethanoic acid would be increased. Perfect. Question 24. Which of the following shows how the equilibrium yield of hydrogen and value of the equilibrium constant affected by changes shown? Effect on equilibrium yield. Reason I cross both of them out, and I can also cross out D. So now what does that leave me with? C. Because only temperature can affect the value of Kc. So A is wrong because it says it decreases the effective value of Kc. Only temperature can, pressure won't. B, the reason I crossed out is because it says it increases the effective equilibrium yield of hydrogen. Catalysts have no effect on equilibrium yield. And D, the reason I crossed out is because it says it increases the effective value of Kc. Only temperature can. Do I need to check it? No, because the answer is clearly C, because only temperature can affect the value of Kc. The graph shows the equilibrium percentage of ammonia present during the formation of ammonia by the Haber process. You can clearly see delta H is negative, so the forward reaction is exothermic. So I need to do a bit more, like just that sign tells me a lot. Therefore, the backward reaction is endothermic. And what can we see from the graph? We can see that it's curve for the graphs. Curve B clearly is lower, significantly lower than curve A. Curve A is, it's got a nice peak to it. Not peak, but you know what I mean. It's quite significantly higher. So reason being, well, also what are the correct labels for the graph? A, x-axis is temperature. B, x-axis is temperature. So let's say the x-axis is temperature. Temperature. Curve A has a high pressure. Percentage of ammonia present. Well, if it's a high pressure, it's going to shift to the side with fewer moles of gas, which is the right hand side, and therefore ammonia would increase. Low pressure is going to shift to the side with more moles of gas, the left hand side, therefore the ammonia would decrease. So that makes sense. Let's look at the other options. B, temperature, low pressure for A. Well, if low pressure can shift aside with more moles of gas, therefore that would be lower than B. So it's not B. C, pressure, curve A, high temperature. Well, if it's a high temperature, it's going to shift us to the endothermic direction to oppose the increased temperature, and therefore the ammonia would actually wouldn't be increasing like that. It would be significantly smaller. Lower pressure, low temperature, it's going to shift to this exothermic direction, therefore there will be more ammonia. High temperature is going to shift to the endothermic direction, therefore there will be that. That makes sense though. So which one is it? Pressure, low temperature, I think the answer is A, but we'll have to have a look at it back when we go through it again. Question 20. What is the value of the equilibrium constant Kc for this reaction? In an experiment, 4.2 moles of carbon monoxide mixed with that. When reaction reaches equilibrium, that much of hydrogen will be formed. Okay, so what we have to do, firstly draw a table. Carbon monoxide, steam, carbon dioxide, hydrogen, I, C, E. We don't need to do MP because that's for Kp. Initial moles, well, we've got 4.20 initial moles of carbon monoxide mixed with 2.0 moles of steam, water, and we know 1.60 moles of hydrogen had been formed, and that was the equilibrium moles once the reaction reached equilibrium of hydrogen. Okay, so that's there. So that's the change is 1.60. Therefore, this change is 1.60. Therefore, this change is minus 1.60, 0.4. And this change minus 1.60. 4.20 minus 1.60, 2.60. Value of Kc. Kc equals products to power P divided by reactants to the power R. So it's going to be my products 1.60 times by 1.60 divided by 2.60 times by 0.40. And I get 2.46. There we go. 31. When 1 mole of ammonia is heated to give a temperature 50% compound dissociate and following equilibrium, establish what is the total number of moles of gas present in this equilibrium mixture. This is a bit of a tricky one, but the idea is we've got 1 mole of ammonia, 50% of it dissociates, so only left with 0.50 now. And then following equilibrium, establish what's the total number of moles present in equilibrium mixture. Well, 1 to a half ratio, molar ratio, so that's going to be 0.25, and that's going to be 0.75. So all we need to do now is add them all up. That's 0.75 plus 0.75, 1.5. And forget the answers, I need to go through a couple more. Okay, this one is not so difficult because it's just a simple question. What is the total number of moles in an equilibrium mixture? So if I use this method and it is successful, then we should get the correct answer. A, B, C, and D. It tells me a mixture of 10 moles of A, 10 moles of B left to reach equilibrium. The equilibrium mixture contained 4 moles of B. So that's a change of minus 6. However, it's a 1 to 3 molar ratio. So if that's a change of minus 6, that's going to be a change of minus 2 because of 1 to 3 molar ratio, minus 2. So that's 8. It doesn't tell us initial moles of C and D, so therefore we're going to assume it's 0 and 0. And because we minus 2 on for A, we're going to add 2 for C. And that's a 2 molar ratio, so we're going to add 4 for D. Then we just add them all up. 8 plus 4 plus 2 plus 4. 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 4 is 18. So the answer is 8C. And in question 23, this one does look very difficult. Hopefully it's not. And if it is, well, I'll try to attack it as I can. So ethanoic acid reacts with ethanol, the reversible reaction represented by equation experiment. That much of that was mixed with that much of that. When reaction reach equilibrium, that much of water being formed. Percentage of ethanoic acid converted to ester is. So what I think we need to do is find out the equilibrium moles of everything. Obviously already know the equilibrium moles of water, and then I can work out the percentage of ethanoic acid converted into the ester. Okay, before I do that, I'm just going to go quickly to the toilet. So I'm back. Back again. So question 23. So like I was saying previously, find out the equilibrium moles, and so let's do that. So using the ice method, we've got CH3COOH, then we've got C2H5OH, we've got CH3COO C2H5, we've got H2O. ICE. Initial moles, changing moles, equilibrium moles. So initially we had 3 moles of ethanoic acid mixed with 1 moles of ethanol, and when the reaction reached equilibrium, 0.9 moles of water had been formed. So 0, 0.9 plus 0.9, 0 plus 0.9, that is also 0.9 moles. In this case we're going to subtract 0.9, 0.1, subtract 0.9, 2.1. Now we've got all the equilibrium moles, but it doesn't want that. It wants the percentage of ethanoic acid converted into the ester, this. So what I think it wants me to do is do the equilibrium moles of ethanoic acid divided by the initial moles of ethanoic acid. So 2.1 divided by 3 times by 100. 70%. So it clearly does not want me to do that. Percentage of ethanoic acid converted into ester. Oh, 0.9 divided by 2.1 times by 100. Because this is the, the equilibrium moles. This is the total equilibrium moles of the ethanoic acid, and this is the ethanoic acid equivalent to ester. So the answer is C, 43%. Now if I mark it, question 3C, question 24C, question 8D, So question 8 was actually D, it was not A. And that does make sense, because if it was temperature, well then we're increasing the temperature, well then it's going to shift to the opposite direction. That's why. Whereas with pressure, we're increasing the pressure, it's going to shift to the side of the fuel moles of gas, ammonia. Okay, so that makes complete sense now, so that's fine. 8D, question 22C. Where's 22? 22C. 20D. 20D. Yep. 23B. Ooh, I got 23 wrong. And 31A. 23B. 30%. I clearly did the equilibrium moles correct. Well, why is it 30% though? Percentage of ethanoic acid converted into the ester that. Oh. No, I thought it was that. It's clearly not that. If you do 0.9 divided by 2.1, yeah, that won't give me the correct answer. 2.1 divided by 0.9 times by 100. Again, not the right answer. So how do I get 30%? Okay. So initially, the moles of ethanoic acid, because it's asking me the percentage of ethanoic acid. So initially, the moles is 3. Converting to the ester, this in this reaction, or the equilibrium moles of the ester, 0.9. So it's just going to be 0.9 divided by 30 times by 100. 0.9 divided by 3 times by 100. I don't know why I said 30. And then you would get 30%. So that makes sense as well. And that is the end of the multiple choice questions. You know, these questions, obviously I got 2 wrong. That last one that I just did now, that was tricky. I've never seen that kind of percentage of this converted into this, find the equilibrium moles, and then do the equilibrium moles divided by the initial moles of something else. Bit tricky. But I hope hopefully you guys found it useful.